Okay guys, this is going to be about lesson 9.1. Now just to mention that 9.1 and 9.2 in class, we did combine both lessons together, so we did skip a lot of the stuff in class, but we did keep, what's most important. But for these videos, I would still like to go over the full lesson with you guys, just in case you guys, take this time and look over the full things, okay? Now, for Unit 9 here, we're going to learn about quadrilaterals. Now, quadrilateral is any, four-sided figures. A figure has four sides, that's going to be a quadrilateral. Now, for lesson 1 and lesson 2, we're going to learn about properties of parallelograms. Now, a parallelogram right here is a quadrilateral whose opposite sides are going to be parallel. So what this means, here's the shape. It's four-sided, it's going to be a quadrilateral. Now, it says opposite sides are parallel, meaning this side right here will be parallel to its opposite side, which is this side. They are parallel, which means this is why I have this parallel sign right here. Okay, this also means that this side will be parallel to its other side, which is right here. These two are going to be parallel as well. This is the definition of a parallelogram. Now, it happens to be that when you have a parallelogram, these following things are true here. Okay, these are called theorems of parallelograms. It happens to be that when you have a parallelogram, first, opposite sides are going to be congruent. What this means is that your AB here will have the same length as DC. They will have the exact same length. Let's say your AB is 8, then this means your DC will also be 8 in a parallelogram. Next one, your opposite angles are congruent. Well, let's say if this angle right here is this 60 degrees, then its opposite angle right here will also be 60 degrees. They're going to have the same angle measurement. Same with this angle right here. Let's say this angle right here is 120. Let's say this angle is 120. It will be the same angle measurement as its opposite angle right here, because opposite angles in a parallelogram are congruent. They have the exact same angle measurement. Okay. The third one is that diagonals bisect each other. Usually when we talk about a line, if we have a line here, and we're talking about a line that bisects through this line here, then this bisector makes your original line in half. This means if this is 1 here, this will be a 1 here. It splits your original line in half. When it says that diagonals bisect each other, it means that when they bisected the lines, it makes it into half. When it bisected this line, it makes these two into half. Okay, so with your parallelogram, it happens to be that AE here will equals to EC, because your line right here bisected your original line right here into half. So this is why this is the same length as this. And same thing with my other one. My line AE here bisected my line B and D. So therefore, this length right here will be the same as this length right here. This is the definition of bisecting. So when we have a parallelogram, just remember that this length right here is the same as this length. This length right here is the same as this length. Okay, now let's look at the next statement. Consecutive angles are supplementary. Now, consecutive angles meaning angles like, on the same side or next to each other. So this means that A and B will be considered as consecutive angles. Okay, angle A and B are consecutive angles and they're supplementary. Supplementary means two angles adds up to 180. So A and B must add up to 180 degrees. Now, this also means another pair of consecutive angle in my parallelogram will be A and D. They are also consecutive because they are also on the same parallel lines. They're also next to each other, so they also add up to 180 degrees. And so does with my angles D and C. They also add up to 180. And so does my last one right here. They are also consecutive angles, which they also adds up to 180 degrees. Okay, now just so you remember, a very easy way to remember is as long as they're not opposite in a parallelogram, they are going to be consecutive. Okay, now let's look at example 1 here. Now these two periods we did not go over